Welcome to day 32 of Math 111. In this lesson, we're going to be looking at computations with decimals. Before we get into the computations, let's review the place value when we are dealing with decimal numbers. You'll see in the diagram in the lower right, we have a decimal representation of a number here, and we also have the place values identified. We have the number to the left of the decimal, which we've been working with previously, 56. We have the tens and the units there. To the right of the decimal, all of the place values have names that end in the letters THS. Learn how to spell these correctly. Also, pronounce them correctly. The first position to the right of the decimal is tenths. The second position is hundredths. The third position is thousandths. The fourth position to the right of the decimal is 10,000ths. The fifth position to the right of the decimal is 100,000ths. Many times in directions when we're talking about rounding, the instructions will say something about rounding to the nearest tenth or nearest hundredth or nearest integer or something like this. Let's look at some examples using this number. Round to the nearest whole number. That means we will not have any decimal places. Because the 6 is followed by a 7, we're going to round the 6 up to a 7. When we round this number to the nearest whole number, we have 57. When we round this number to the nearest tenth, we'll get 56.7 or 56 7/10. You'll notice that 2 follows 7, and since 2 is not 5 or greater, then the 7 remains the same. In the third example, round to the nearest hundredth. We want to round to 2 decimal places. We look at the second place to the right of the decimal point, and we see a 2. The 2 is followed by an 8, and because the 8 is greater than or equal to 5, then we round the 2 up to 3. Our answer is 56 73/100ths. The next one, round to the nearest thousandth. We want 3 decimal places in our answer. The third position to the right of the decimal has an 8. The 8 is followed by a 4, and since this is not greater than or equal to 5, we do not round up. We leave the 8 as it is. Our answer is 56 728/1000ths. And the last example, round to the nearest 10,000th. We want 4 decimal places in our answer. The fourth decimal place is occupied by a 4. It is followed by 9, and so we'll round the 4 up to a 5. Our rounded answer then is 56 7,285/10,000ths. Let's move to operations with decimals. When adding and subtracting decimals, we use our normal algorithms. We do have to make sure that we take care in lining up our place values. So we usually identify this by lining up the decimal points vertically. Let's look at a couple of examples here. In the first example, we have 23 4/10 plus 18 15/100. You'll notice that whenever I set this up vertically, I line up the tens digits, the 2 and the 1. The units digits are lined up, 3 and 8. And then the decimal points are lined up as well. The 4 is in the tenths position, and so is the 1. And then I have 5 in the hundredths position. So you'll notice in the example, everything is lined up by place value. And then I add as normal. When your digits are lined up like this, the decimal point follows. With subtraction, we do the same thing. We take care to line up the place values. I have 12 513,000ths minus 9 64/100ths. And again, the decimal points line up. I subtract normally, and again, the decimal point falls into place below the other decimal. I subtract normally, And my answer is 2 and 873 thousandths. We have a note here, just to reiterate what I was saying. Notice that the digits are vertically aligned according to place value. This is why we say that the decimals must be lined up. Let's move to multiplication. We use our normal algorithm for multiplication. The placement of the decimal point comes at the end. And to find the position of the decimal point, we count the total number of digits to the right of the decimal point in all of the factors. The product should have the same number of digits to the right of the decimal as the total number of digits to the right of the decimals in the factors. Let's look at an example. We have 1 and 25 hundredths times 2 and 3/10. We do not have to worry about lining up the decimal points when we multiply. We go ahead and multiply normally, and then we count the number of decimal places to the right of the decimal points at the end. So we use our normal algorithm to multiply 125 times 23. You can see where I've multiplied there. And then I start counting the digits to the right of the decimal points. In 1 and 25 hundredths, I have 2 digits to the right of the decimal point, and in 2 and 3/10, I have 1 digit. That's a total of 3 digits to the right of the decimal. I count off 3 digits and place my decimal point so that 3 digits are to the right of the decimal point. This gives me 2 and 875 thousandths. With division, we eventually use the standard algorithm for division. But before we can begin dividing, we have to think about moving the decimal point if the divisor contains a decimal. We move the decimal position the same number of places in both the divisor and the dividend. We can justify this by multiplying both the divisor and the dividend by the same power of 10. Here's an example. 124 and 8/10 divided by 3 and 12 hundredths. The divisor is 3 and 12 hundredths. So we have the division problem set up here. The divisor has 2 digits to the right of the decimal, and the dividend has 1 digit to the right of the decimal. I'm going to have to move my decimal point 2 places to the right. In order to do this, I'm going to have to add a 0 to the right of the 8 in the dividend. After moving the decimal point, I have 312 as my divisor, and the dividend is 12,480. I go ahead and divide normally with long division. 312 goes into 1,248 4 times, and it goes evenly. So then I have to add a 0 for the units place. The 4 is in the tens place. I have to place a 0 in the units place as a placeholder. So the quotient is 40. We will end with scientific notation. Scientific notation is a way of writing numbers as multiples of powers of 10. The decimal point always follows the first non-zero digit. You'll notice in these examples that the exponent on the 10 matches the number of places that the decimal point has been moved. So we can write 235 in scientific notation as 2 and 35 hundredths times 10 squared. We move the decimal place 2 points to the left. 45,255 can be rewritten as 4 and 5,255 ten thousandths times 10 to the 4. And you'll notice the decimal point was moved 4 places to the left. Our third example is 2,357 ten-thousandths. We want one non-zero digit to the left of the decimal. So we'll move our point 1 place to the right, and that will give us 2 357 thousandths. And because we moved the decimal 1 place to the right, our exponent is -1. And finally, you'll notice that we have this decimal representing a very small number. You've got your decimal point, then there are 4 zeros following it, and then 88. We move the decimal point so that there's one non-zero digit to the left of the decimal. That gives us 8.8. And we move the decimal point 5 places to the right. So our exponent is -5. 8 8/10 times 10 to the -5. All right. So again, notice that the exponent is related to the number of places that the decimal moved. We can reverse this process by converting numbers in scientific notation to standard form. 4 25/100 times 10 to the 5th in standard form is 425,000. The decimal point will be moved 5 places to the right. Frequently, we will have to add zeros as placeholders in order to accomplish this. Our next example, we've got 3.15682 times 10 squared. To get in standard form, I'm going to have to move my decimal point 2 places to the right. So the decimal will move to the position between 5 and 6. That will give me 315 682 thousandths. The third example here, we have 2 3/10 times 10 to the -4. You'll notice that when you have a negative exponent, then you have a representation of a very small number. We must move our decimal to the left 4 places. We'll have to add some zeros as placeholders to do this. The result is going to be a decimal point followed by 3 zeros and then the 23. 0.00023. And our last example, we have 5 36/100 times 10 to the -2. Again, the -2 tells us that we've got a small number. We'll move the decimal point 2 places to the left. And in order to do this, I'll need to add a 0 as a placeholder. The result is 536 ten-thousandths. So again, notice the decimal moved 2 places to the left. The topics that we've covered in this lesson today are really not new to you. This is review for you. Make sure that you remember the rules for operating with decimals. When you add and subtract, remember the place values must be lined up, so the decimal points are also lined up. When multiplying, the product has the same number of decimal places as the sum of the decimal places in the factors. And when dividing, our algorithm has us move the decimal out of the divisor, and so we have to move the decimal the same number of places in the dividend. And we ended up with scientific notation. Scientific notation is a way of writing numbers that are more convenient to work with in some settings, especially in science.